everyone, welcome back to the man cave. We've got updates. So we've done some rearranging, done a little bit of cleaning up to get ready for the next project, which I know, I've been promising that we were going to get the cyclone done. Upon looking at things, cyclone was a little bit more in depth than I had originally anticipated on. So we put it on the lift. We put the 51 back on the floor. I have almost every part I need to finish the 51, almost. So yeah, that's actually the next project. But first, there's always a side project, and here's the side project. Acquired this bandsaw, and it's Powermatic bandsaw. It's a wood cutting bandsaw. If you don't know, wood cutting bandsaws run at a really high blade speed. I think this one runs at like 3,000 RPM. Metal cutting, you need somewhere around 75 RPM. So I've looked at the pulley sizes. I've done a lot of figuring and looking at what I can do, and I have some step pulleys and different things. Then I was looking at going to speed control on the motor, but this motor is not designed for speed control. So this is what I did. We ordered a 41 gear reduction box. So having this 40-to-1 gear reduction box should allow me to put my motor input here, and it should be reduced by 40 times here. So now what we have to do is figure out how to turn the motor the other way and mount it on the frame, attach it to this drive, and then make a shaft that will attach this drive to the drive pulley for the bandsaw. So that's what I'm going to work on today. But the very first thing we're going to do is we're going to actually check what the RPM is on this blade drive wheel and see if it's coming up to what my research had said this would be, which would be a blade speed of around 3,000 RPM. So we're going to test that first. So you got some reflective strip that comes with these things. You just cut off a little piece of this. Now, if you try to put this reflective strip on a shiny shaft, it does not work quite as well because it's reflecting the beam back to the monitor there off of the shaft also. So it's kind of difficult. You have to put some kind of backing behind it, some kind of tape or something behind it to keep that reflection down. Let's see if we can get this off here. Now, as you notice, I do not have a blade on here right now, and that was on purpose. Now, the motor on this runs at 1725, and then there's some really nifty calculators online. You can put in the size of your pulleys and get your RPM. So I have my pulley size for my driven pulley, which is the one on the motor, and then I had pulley size for my drive pulley, and then the blade speed equates out to these being 14-inch. This is considered a 14-inch bandsaw. So that information plugged into the 14-inch size supposed to equate out 3,000 RPM. So the cable on this thing's a little janky. I've got a new cable to put on it, but for testing purposes, I'm going to plug it in and hope we don't get electrocuted and see what we end up at, because all this has got to come off to do what I need to do anyway. Okay, plugged in. I don't see any smoke yet. Let's hit the start button and see what we get real quick. Woo! That's moving. But roughly 850 RPM, 847 is what it's registering at. However, the math equates out to go from 850 RPM on that pulley to 3,000 blade speed is whatever. I mean, I can figure it out, and then we can figure out what we need. But basically, I need a 40-to-1 reduction. At least that's what we're going to try. If 40-to-1 don't work, they make different reduction gearboxes. They're not all that expensive, but it doesn't have an RPM range on it that I saw, which, we're turning at 1725 there. So let's get this puppy turned around, and we'll pull the cover and stuff off the back. We'll get the motor and everything off and do some measuring and see what we got to do to match everything up. Hopefully, we will not have to change any pulley sizes at all The expectation is just to have to make a couple of shafts, which I got some material here to do that with. We've got the lathe and all that stuff back up and going now, so we should be good. Let's get on it. This should be fun. Alrighty, so here's where we're at. Got the motor and all off of the bandsaw. Got everything here on the bench. And let me show you what we got going on. So, this is our driven side. Obviously, this is our motor. I did not take any measurements beforehand, but we are just a hair off of being the right size for this just to slide up on here. Then it would just be a matter of making a bracket that would bolt up in that same location. Then I just need to make a shaft come out, mount my pulley on, and I think we'll be golden. As long as I mount it in the right direction so it turns the correct way, which I didn't pay any attention to. We'll have to figure that out. But anyway, all right, so here's where we're at. This 14 millimeters. Shaft on my motor, 16 millimeters. I tried disassembling this. Well, I did disassemble it, but could not get this particular shaft out without taking the seal off the back and removing a snap ring, which is unfortunate because I would love to have chucked this up in lathe and machined it out to 16 millimeters. Since that's not really the option right this minute, I have thought of two different scenarios. One of them is I can put this in the milling machine, lock this down so this doesn't move, and bore it out with a boring head. And we may do that. But the other thing that I'm gonna possibly look at doing is quite a bit more shady. And we're gonna look at possibly grinding this shaft down. And when I say that, I'm thinking of attaching this to the bench, plugging it in. I've got a switch set up here. I can turn this on, take the grinder, and let's see if we can turn that down to 14 millimeters. Yeah. The question is which is the least questionable? I'm thinking right now, if I anchor this down to the bench here, take the keyway out, and spin this thing, I can get my distance that I need off of this, and I can always go back and remachine that keyway in if need be, to get it just a little bit deeper if I need to. I don't know as if I will, but we're not talking about a tremendous amount of difference here. So let's test a couple of things and see what happens. All right, well, my attempt at running the motor and grinding down the shaft, and that failed miserably. It kept hitting the keyway spot, and it just was all off center, and it just was not going to work. So I went back to playing, I don't know, Q or F or whatever it was, and put it in the milling machine. See, what we'll do now is I'm going to bring this in, touch off, start my fly cutter, start my motor. Okay, that looks pretty good right there. So now, need to measure it again. We'll try it and see if we can cut this down. All right, so I got updates. I cut the shaft down, and then I got to thinking, I mean, it's got to be, it's too small there anyway. But I got to thinking I needed a coupler. So I got a couple of different sizes. The shaft coming, the input shaft going into the gearbox is 14 millimeters. So this is 14 millimeter on this end. This is 12 on this end. So I figured, hey, worst case scenario, I could machine this out, fit it on there, because I think we're closer to, I don't remember, ½ inch or so on this. And so I was going to do that. And then I had another bright idea. Let's just look at getting a different motor for this. So I got to looking on the Jungle website, and I came across a DC motor, sewing machine motor, that I wanted to try. And so I ordered it. It came in around the same time as that stuff. So while it was coming, I actually went through, did a bunch of work on the saw itself that I didn't record. I'm sorry. If you want me to really go over it in detail, I can, but it's pretty simple. So got all that cleaned up, got everything where it was aligned right, got the pulleys aligned, got the blade aligned. I got a 3/4 inch metal cutting blade on it, and the motor came in. So here's what we got. All right, so there's the motor. I kind of took it apart because this thing was actually originally designed to mount underneath a sewing machine. So here I actually have it mounted upside down. I took the controller off, just set it over to the side so I could get to it, hooked it up, got the belt tight, and voila, it will start and run. And I'll start it here for you in just a second, but it will start and run. But the issue is this motor is adjustable from 200 RPM to, I don't remember, 3,000 or 4,000, something like that. I don't remember, crazy speed that we definitely can't use on this, because that, you know, if you remember, our other motor is 1,800 RPM roughly, and that puts this blade speed at 3,000. So we actually needed our RPM lower than 200 RPM, but we needed it lower than 200 RPM, but I thought, hey, maybe it will work at 200 RPM. So here's what we've got. So let's see what we can do about getting the gearbox mated to it. I don't want to say the problem is, but now, and you can order shafts for these things through Amazon, but what I need to do is I need to make a shaft for that gearbox to hook to the pulley to go to this, and then I need to make a shaft to come from the gearbox to couple to the motor. And I think the coupler that I have over there in the 12mm size will actually fit on the end of this motor, so I think we'll be good there. And so, whoops, we're gonna fire this up and plug it in, power on. We can set our speed here. Right now, let's see. If I set it at 200 RPM, belt's under tension, blade's under tension, everything's tensioned where it should be tensioned at. And here's what we end up with. I think the actual blade speed would be doable at this RPM, but the motor's not happy running this low. And I don't even have a load against the blade to try to cut something, so I don't think that'll work. I can go right on up with speed though, and let's go up to 1,800, and this is where it was running at originally. It's loud, but it would live there. So I think what we're going to do is we're going to adapt the gear reduction box to this motor. And that should slow our blade speed down, but keep our motor in a spot where it's happy. All right, so I know I said we were going to start with shaft, and I'll show you what we got here. So the shaft that we wanted to couple this stuff with would have been from here to here. And that's fine, because we're just going to make a little stub shaft come out, connect to our whichever union it is we decide to end up using, and then connect to the motor. One of the tricky things about the motor is that the pulley on these have a tapered fit onto that shaft, and this did not catch it, of course, when I 3D scanned it. But what I ended up doing was making an adapter to fit on this shaft with that tapered fitting that would slide into the coupler that we ended up using. So that was, that was one of the things that I had to make. You could just sacrifice the pulley and cut it off and then grind the fit inside the coupler that you're going to use. So there are ways around it. But anyway, I got it to work. This shaft here, I've got my dimensions on. It will bolt up on this side. It's threaded for over here. A bolt washer and a lock washer to hold this shaft in, and it's keyed inside. So that all worked out well. The rest of my overall design, I had to 3D model this because I couldn't find anything that was, close. I didn't go into a tremendous amount of detail about ribs and stuff, but I did not know for sure what I was going to need as far as bolt hole location. So I did make sure that I was accurate on modeling all those and my bolt hole locations here for the front. And obviously we wanted to make sure that they were modeled on the bottom. So after getting the bolt hole locations and all modeled in, and my overall dimensions, all that stuff. I was able to design my support bracket that I was going to use. I was able to design my adjustment brackets, which include a lot of adjustability here on the bottom because I didn't know exactly where at inside the machine it would end up. I 3D scanned the motor, as I said just a few minutes ago, and that gave me the opportunity to figure out my hole location here, and how wide I needed this lower bracket, how high up I kind of wanted it to get the centers, you know, as straight on as I could through here, which there's still going to be some adjustability because I have a shaft that's with this threaded nut and another nut on the top to lock it in place. Now, one of the things that I did end up doing to save on material, I ended up, let's open this one up. This is my cut plans that I used for the plasma. And I ended up cutting out a big circle here to put the bracket in. This is the DC motor mounting bracket. This is the support brace for the other part, for the gear reduction motor. So we've got all that in, and we cut it all out, and then the other pieces I cut out separately. That's these here. Let's see, flat pattern. We'll activate that. That's what it ended up looking like, and then I was able to just take the flat pattern and pull it in. Now, some of the things I did do to check and make sure things were going to fit like they should before I cut all this out of metal was I was able to save these, export these as a DXF, and I sent it to my laser, and I actually cut this stuff out of cardboard. So then I was able to kind of mock it together with cardboard to make sure everything was going to fit up the way I wanted it, to make sure that our bracket here was going to fit the way that it should, to see that all my holes lined up, see that all my holes here lined up, because it did have, I think, a little bit of adjustment I had to do here and there, but nothing crazy. But yeah, that's what I did to model this thing up to be able to design the plates, and it worked really, really well. You know, as you'll see here in a few minutes how it ended up turning out. All right, so we just went over the process of, you know, what I did to design the stuff for this motor and all. So now we're going to cut this thing out on the plasma. So I'm going to bring you over here and let you see how this works. Anyway, here we go. All right, so as you can see there on the screen, I've got it laid out in the way that I showed you just a few minutes ago. So I imported it into OpenBuilds CAM, since that's the system I'm using now. And so here, I'll turn you and let you see what that does. As you can see, somehow or another, we missed that one slot there. I'm going to go back on my original, try to put in that one slot and just cut that one slot out. Hopefully that'll work. Always got to pay attention. If you can see it on here, I would have watched, I would have noticed that this slot here was not included on this one. And somehow that's just the way I brought the information in, but I think I should be able to correct it. I didn't pull anything off the table. Everything's still lined up. So I'm just going to go back and insert that one in and leave everything set exactly the way it is. Thank goodness I didn't get ahead of myself and start snatching stuff off. But what I did was I went back to Fusion 360 and I just set to cut that one slot. So what we're going to do now is we're going to close this G-code out. I have not moved anything. I have not changed my XY coordinates. That's one thing you want to make sure you don't do, because there is a set 0, and if you accidentally hit that, it's going to throw everything off. Everything still remembers where it was, and that's what I want. So what I'm going to do now is I'm going to come down here to G-code editor, clear it. I'm going to go back to my 3D view so I can see, so there's nothing there. We want to load the new G-code that I just modified, which I just named slot. And there. And if we zoom down, we can see where it's at. Now what I'm going to do is I'm going to turn the plasma off, because well, first thing I can do is check position and see if it's going to cut in that spot. So I want to go to 0. Which go to work coordinates, which is what I had set originally. which is where it's at. I'm going to bring my Z up. I can do it continuously because I don't want it. If you don't bring the Z up in here, it won't automatically bring it up when you check your size. So now we'll check the size. It should go right to that area where I want to cut. And it's going to kind of check the size of that spot, which it, you know, even though it's not going to be cutting, it wants to make sure it's going to be in that area. Now I can turn the plasma off. And this plasma takes a second for it to wind down. Once I turn it off, I can actually hit run, and that's how you can simulate your setup to make sure that it's going to run to where you want it to. As soon as this plasma winds down, there it goes. All right, so what we're going to do now is I'm going to hit run, and you'll be able to see that when I do that, the plasma is going to take over, and it's going to go to the spot where I had the issue, and hopefully do like it's supposed to do. So I'm going to make sure it doesn't jar and wiggle and move. Because it may not be in exactly the right spot. So when it touches off, it's going to try to pick it up. So I need to... All right, great. So what I need to do now is when it touches off to make that cut, I need to make sure I've got a way to hold this to keep it from twisting. And I can do that with this heavy piece of steel. I just need to make sure that when this thing comes back around, it doesn't crash into it. And I'll turn the plasma back on and we'll try this again. So, all right, we're going to hit start. And I'm going to try not to block it as much as I can, but probably will. All right, so that's kind of how you correct one of those issues. I just missed something somewhere. I don't know what it was, but that's how you can correct it. You know, look at the part before you move it, take it off. If it would have been this one back here, we probably still could have done it, done the same thing. Let's pull these off. Let's put it in the bender over there, and let's get our 90-degree bend in these and see how everything's going to work. All right, here we go to the bender. Got my parts cleaned up. Nice thing is I only need one bend on these. Again, I've got my little slots there in the edges of it the way that I showed you last time. I only want a 90-degree bend, so it shouldn't be an issue. We'll spring this down. Get it set up where we want it. Let's see, we want it right in that bend. I did not draw a line on this one, but I know one I want to go one way, one I want to go the other way. So, it should be, I can't really get a gauge on it to check, but we can always tweak it a little more if we need to. It's a little over, as you can see, it's a little over bent, but I can tap it back around to get it where I want it. So the next one I know we won't need to go that much. So this one we had in this way. This one we want to go in this way so we get the opposite bend out of it. So they go on this side here. We want this reverse of the other. Alrighty. All right, as you can see, we got our two little handy dandy brackets here. We're going to come over to the bench next and see how they fit up and see if it's going to actually do what I want it to do. Anyway, there we go. So let's get over to the table and see what we can make happen. All right, so the way I designed this to work is these holes here line up with these slots, which will give us a lot of adjustability front and back if we need to. But this will pivot on that hole there That will allow us some room for belt adjustment and belt tension. And that's, you know, that's what I was hoping to have. Obviously, with the way the belt runs, it's straight up and down, so that arc will work just fine. So let's get this thing tore down. Let's get it broke down. Let's get our pieces tacked up, and let's get some welds thrown on this thing, and let's throw it in the bandsaw and see how it actually works. All right, so we've made a little bit of progress off camera. What I've done is I went ahead and mounted the motor and, you know, got all welded up the bracket. Y'all didn't need to see me welding up brackets and junk. So let me show you what we've got. There it is in all its glory. It turned out really, really nice. As you can see, I went ahead and mounted the controller and stuff in the up front side of it, and I'll show you that in just a second. But the belt adjustment for the tension and everything worked out phenomenal. I mean, I only had to get a belt that was about 2 inches shorter than the one that came on it. That was great. I mean, my slots allowed me to line it up with slots that were in the current plate already for the other motor. So all that worked wonderful. So let's go around on the other side and I'll show you what the... So there's the controller. What I did was I made me a template, cut it out on the laser, and I was able to cut construction paper and put it on here to cut my openings to mount my controller and on-off switch. And then I use that same template, same DXF drawing CAD file to 3D print a cover plate for this so it doesn't look so ragged. But yeah, man, this thing works great. A little orange doohickey sticking out, that's the controller. That's like if you had this thing on a sewing machine, you'd have a foot pedal. That was just something quick I did to give this thing a test. And yeah, I mean, my controller and all set up. So let's turn this thing on and see what it does. I don't know exactly what the blade speed's running at, but it seems to cut through thicker stuff pretty decent, so I'm okay with that. The blade that I have on it's pretty aggressive, so trying to cut really thin stuff might be an issue. But this is how we operate it. All we do is throw it over and it locks in place. Bandsaw's running. And when we want to shut it off, we just simply pull her back over and it's good to go. Still can adjust our RPM down there. I've tweaked that a little bit. But anyway, that's the whole mechanism, man. It ended up working out wonderful. Hey, there was a couple things that I realized when I was editing this video that I forgot to do. And one of those was verifying the new RPM on the motor to make sure the gear reduction box is working like it's supposed to. So, of course, as you just saw, everything's set up. I set the speed on the controller to 1800 RPM, which is roughly where the original motor was running. And we're going to turn it on and check the RPM on this puppy. Alright, so our sticker's right there, got the tachometer, we're going to shoot it. And let's start this thing up. It's considerably slower than it was before, so. So that's like 22. I don't remember where we were before, but it's considerably less. So I'll run the numbers on it here in just a second and see, but that's 22 RPM at the same speed we were at the last time. Alright, so let's give this puppy a little test. It's got some scrap 1/4 inch plate here, and we're going to run it through it. Alright, did a pretty clean cut. You know, a little bit on the slower side with this blade on it. This blade's really meant for doing a little bit thinner stuff. It cuts through it pretty quick here. We'll do a little bit thinner piece. Let's see here. We got some. It's about 1/8 inch here. Let's do this. Yeah. So overall, I think that's a win. I'm happy with it. Does what I wanted it to do. It's better than trying to cut it with a grinder or something like that for no more money than I got in it. I do have a more aggressive blade if I was going to be cutting thicker material, and it's not hardly anything to switch blades out on this. But the blade speeds, just need to play with it and get it there. I was running at about 4,500 on the motor, which I think is going to put me somewhere in the neighborhood of 200 feet per minute on the blade. You know, the nice thing about it is I could have went with the other motor like we started doing, but I would have had no adjustability. And with this, we have the capability to adjust the speeds. We want to cut the aluminum, we can speed it up. We can cut the harder stuff, we can slow it down. Doesn't take up a huge footprint in the shop. Yeah, I'm pleased with it. I think it's going to work out well. We'll see how long the motor holds up, but so far I think it's doing okay. I don't see any issues as of this moment. But yeah, if you got any questions, you know, shoot me a line, drop me a message, and I'll be happy to respond back. But I appreciate y'all watching, and keep checking back for more. Y'all have a great day.